Something that we frequently need to explain to our customers is the cost of workstation parts. For a lot of people, a workstation winds up looking the same as a purpose-built gaming rig. Now, gaming components are plenty performant and can have impressive lifespans if you take care of them right. They're also a lot cheaper than workstation components, at least when purchased new. Why is that? And when you need which part? I'm going to explain this for a couple of different components, and I want to start with RAM. ECC memory is an example of something that is entirely absent from gaming PCs, and it's a bit more difficult to explain the reason why you might need it. Error correction code memory detects and fixes single-bit memory errors caused by electrical interference or even background cosmic radiation. These errors also become exacerbated at higher RAM speeds and are further multiplied as you use more and more RAM. Think of it as kind of like you get bigger in one way, you get faster in another way, and you just have a lot more potential for errors. If you're working on simulations or renders that don't take up a ton of time, you wouldn't really see the difference between your standard consumer RAM and ECC RAM. Now, if you're working on an animation or simulation that'll take, let's say, 72 hours to render, ECC RAM starts pulling its weight because you have this multiplied by 72 hours. That can lead to a lot of errors. And ECC RAM could then save you a ton of time. Sometimes this question is really easy to answer, especially in the case of GPUs. So if you render a scene in Blender or Maya, and your system is asking for 25 gigabytes of VRAM, and you have 24 gigabytes of VRAM, it will look for that RAM somewhere else. That will be your system RAM, and your system RAM doesn't know how to do that job. It will do a very bad job of it. It will do it very slowly, and it will oftentimes just crash the program entirely. Now, workstation video cards, while on average being more expensive, have more VRAM on average than gaming cards. With the buffer of additional VRAM, you can click render and walk away knowing that render will actually complete. As an added benefit, the VRAM in these cards is also error correcting, meaning you won't get blips on higher scale projects. On top of that, in the event that you'll need more than 48 gigabytes of VRAM, workstation GPUs are designed to run in parallel, both in software and in thermal design. Furthermore, that thermal design helps keep the cards running cooler and live longer operational lifespans. Beyond that, workstation video cards are also designed on the software level to handle specific apps. NVIDIA, for example, has specifically developed drivers for their Pro cards to help them run Adobe and Autodesk apps. Entirely different, your MOBO. The frequently overlooked motherboard is responsible for making sure all of your parts can commune in harmony. As you scale up the amount of data and power going into all your parts, though, you put a lot of pressure on the infrastructure running your system. To help alleviate this, workstation motherboards offer more PCIe lanes, up to 128 of them to be exact. This means way more bandwidth for GPUs, as well as the option to run multiple GPUs at once without creating a bottleneck. And in the same way you might need a workstation MOBO for all your GPUs, you need one for all your RAM too. Conventional motherboards can support in the ballpark of 128 gigabytes of RAM, maybe 256. Workstation motherboards support more DIMM slots, along with all the fancy features that come with ECC RAM, meaning you can have up to 2 terabytes of ECC RAM, giving you plenty of headroom to run whatever complex simulation or render that you need to. Now, I'm going to talk about cooling. You might be surprised to find out that cooling for high-end desktops is really much louder than it is for high-end gaming PCs. There's an excellent reason for it too. Your average gaming PC will be using a GPU that uses a few fans in parallel that remove heat by pushing it into the case. The case fans then pick up that air and throw it out the back or the top or wherever your exhaust fans are. This works out perfectly for gaming systems that usually see a few hours of intense use at a time. Workstation units can see much more than that. It's not uncommon for a machine, like I said before, to work the weekend without you, toiling away at a render or a simulation, all the while at maximum capacity. This calls for blower fans that force air through the card even if it's stacked next to other cards under similar duress, at the downside of being really loud. Similarly, the coolers for your workstation CPU are oftentimes not the flashy all-in-one water coolers for gaming PCs, which are quiet and efficient, but big loud blower fans just do a better job. The fans have the capacity to spool up to some pretty impressive speeds and just maintain the necessary temperature to run your CPU under load. So, are workstation parts worth it for you? When it comes down to it, not everybody needs or cares about these features. That's completely understandable. The delta in price between workstation components and consumer components is really, really significant. And you need a really significant reason to make that leap. Oftentimes, that comes in the form of a higher-up or a team or a company relying on your render, your simulation, your project, making it out the other end completely unscathed and on time. If you have the flexibility, though, don't hesitate to get the conventional parts. They're still plenty good and are a bit more applicable to a broader range of tasks. They're good at gaming. I'm saying they're good at gaming. If you can't put a finger on what you need for your next PC, don't worry. Give us a call with the number on screen, or visit us at our website, and we will tailor-make your next PC to fit exactly your needs. This has been Marcus with Velocity Micro. Thanks so much for watching, and I'll catch you in the next one. Cheers.